Hi everyone, this is Top 3D Shop, and in this video we will tell you about industrial 3D printers, covering all the major technologies, their features, and the most noteworthy models of different types. Being around for more than 30 years, 3D printing has come a long way from research and lab-focused machines to household items and readily available tools in your garage. The fast pace of development allows people today not only to use 3D printers as a helpful tool for their hobbies, but to establish new businesses and manufacture high-quality products faster and at less cost than ever before. So, what really changes when the industrial factor comes into play? What distinguishes industrial 3D printers from their consumer counterparts? How can you be sure that a particular 3D printing solution would benefit your business? Let's figure it out. There are several issues worth considering before you pick up an industrial 3D printer. So what you basically need is to print a lot at less cost, print large, precise and fast, and print in industrial-grade materials with minimum downtime. Not long ago, the main technology for making plastic parts was injection molding. The appearance and development of additive manufacturing made rapid prototyping and low to medium batch production accessible to a variety of industries. But what if your design is ready but the production costs are limited by the budget? Can 3D printing become a silver lining which allows for cost savings, thus letting you keep under budget? In short, yes. With injection molding, the upfront cost should be taken into consideration, which is the cost of the mold that is usually no less than a few $1,000s. Besides, it takes pretty much time to cut the mold, while with 3D printing you can start production as soon as your design is ready without any advance payments. The cost per part is generally higher with 3D printing, but if the volume you're going to print doesn't exceed a few thousand pieces, it is more cost-effective than injection molding, considering the cost of the mold. Another important advantage of 3D printing compared to injection molding is the R&D freedom, allowing for design changes at no additional cost, while each part's design would require a new mold with conventional technology. One of the prominent characteristics of industrial 3D printers is that they normally have more spacious build volumes compared to consumer devices. This comes in handy as you can print large objects or multiple smaller parts in one go, thus saving your time and money. Some large format industrial machines boast enormous build volumes of 1 by 1 by 1 meter and more. Among other features that distinguish industrial 3D printers are high-quality hardware and cutting-edge technologies that ensure decent print speed along with consistent high-resolution printing with predictable results. Industrial machines manufacturers usually offer dedicated slicing software and a range of proprietary consumables to provide the best print quality possible. The choice of materials used for 3D printing is determined by the technology your device is based on. FDM printers use spools of plastic filaments, while SLA involves liquid resins. The material used with SLS-based printers is polymer powder sintered by a laser. All these materials are utilized both in consumer and industrial 3D printing, the difference lying in the variety of materials supported by the printer. Entry-level models basically print with the few most common types that don't require special equipment, and that is usually enough for most consumer projects. Industrial-grade machines require a much wider range of compatible materials to complete various complex tasks. Industrial FDM printers, for example, can work with high-temperature filaments, like PEEK or ULTEM, and also with carbon fiber or glass-filled filaments. Metal 3D printers, in turn, is too a tremendous help when it comes to industrial manufacturing. There are also devices which use specific materials, like the Delta Wasp 4100 clay, which was designed specifically for working with ceramics. Industrial-grade machines tend to include such features as automatic bed calibration, a filament runout sensor, an onboard camera, or print farm compatibility. All of them increase the reliability of the process and help to avoid emergencies and sudden failures while printing. Most printers use various technologies that aim at maximum automation, starting with preparing the digital model and through the whole process of printing and subsequent post-processing. Some manufacturers offer complete solutions, like the Raise 3D Metal Fuse, including alongside the Forge One Metal 3D printer, the D200E debinding machine, and the S200C sintering furnace. Such systems not only add to high performance and consistency, but also minimize possible downtime. Now, let's proceed to specific 3D printing technologies and the best industrial solutions available on the market. Fused deposition modeling technology, also called fused filament fabrication, uses thermoplastic filament that is melted and deposited with a nozzle on the print bed layer by layer. FDM industrial printers are arguably the most affordable solution, providing the lowest cost per part. They are perfect for rapid prototyping and even for production of end-use parts with simple designs, but manufacturing of intricate models with particularly complex geometry is hardly their strong point. The Fusion 3D Edge is one of the fastest commercial FDM 3D printers. Utilizing the proprietary F-Series motion control system, the Edge can reach the print speed of 250 mm per second, still providing highly precise and accurate parts. The patented anvil print head heats up to 320 degrees Celsius. The single interchangeable print tube, which comes in 0.4, 0.6, and 0.8 millimeter diameters, is made of surgical steel and is wear-resistant for use with abrasive materials such as carbon fiber or fiberglass. The Raise 3D Pro 3 Plus is ideal for professionals, fulfilling the requirements of large-scale production and multi-sized rapid prototyping. The printer features a larger build volume of 300 by 300 by 605 millimeters compared to the original Pro 3 model. The device has a heated print bed and an enclosed print chamber that allows printing with ABS-type materials. With the dual modular extruder being capable of reaching 300 degrees Celsius, the Pro 3 Plus can print parts with 2 different materials or in 2 colors. Auto bed leveling and an onboard HD camera add to the printer's usability. Powered by proprietary IdeaMaker software as well as LAN and Wi-Fi connectivity, the Pro 3 Plus is a powerful tool for an industrial setting. Designed specifically with carbon fiber reinforced composites in mind, the Raise 3D E2CF utilizes IDEX technology, the independent dual direct drive extrusion system ensuring faster and smoother printing. The Raise 3D E2CF is aimed at engineers and designers in areas such as automotive, aerospace, healthcare, mechanical engineering, and basically any industries relying on the strength and durability of printed parts. With proprietary and third-party carbon fiber filaments available, the E2CF can go a long way in terms of resolution, precision, and repeatability. The Intamsys FunMat Pro 610 HT is an industrial-grade FDM 3D printer, specifically designed for printing with high-temperature filaments. The device features a fully enclosed heated print chamber, a heated build plate, and a high-temperature all-metal extruder with a dual-nozzle system that heats up to 500 degrees Celsius, making it possible to print with PEEK, PEC, Ultem, as well as composites like carbon fiber and metal or glass-filled materials. With the spacious build volume of 610 by 508 by 508 millimeters and the minimum layer height of 50 microns, the FunMat Pro 610 HT is able to print large parts with great precision and accuracy. One of the most notable features of the Mosaic Element HT 3D printer is the proprietary series-enabled multi-material extrusion technology, realized through the built-in Pallet X filament splicer, which allows for printing a single part with up to 8 different filaments of various properties. The build chamber of 355 by 355 by 355 millimeters can heat up to 80 degrees Celsius. Alongside the 500 degrees Celsius nozzle temperature, it enables working with high-temp industrial-grade materials such as PEEK, Ultem 9085, and polycarbonate. The minimum layer height of 20 microns provides highly detailed prints with smooth surface finish. The Element HT can perform as part of the Mosaic Array complex solution for industrial automated 3D printing with minimum downtime. American company IC3D has gained experience in designing custom-built 3D printing equipment, and the IC3D Virago 700 is the company's first commercial 3D printer. The machine features an independent dual extrusion system with the maximum heating temperature of 500 degrees Celsius that supports simultaneous printing with different filaments, including industrial-grade materials such as polycarbonate, polypropylene, nylon, thermoplastic polyurethane, and fiber-reinforced composites. The Virago 700 sports a large build volume of 600 by 700 by 785 millimeters and a heated bed platform equipped with a removable magnetic plate. Featuring a build volume of 600 by 600 by 600 millimeters, the CreateBot D600 Pro has a surprisingly compact footprint, which is great for limited workspaces. The device is equipped with a dual extruder mechanism. The left hot end with the maximum temperature of 260 degrees Celsius is intended for printing low-temperature materials, while the right one is capable of reaching 420 degrees Celsius, which makes it possible to print with high-performance materials like high-temp nylons, carbon fiber-filled thermoplastics, and PC. Unlike the original D600 model, the D600 Pro sports a heated build chamber which can maintain a temperature of 70 degrees Celsius. Size has recently become one of the main market revelations. The increasing number of manufacturers continue to push boundaries when it comes to large-scale 3D printing. Automotive, aerospace, shipbuilding, plumbing, architecture, and arts have been the main fields targeting large-size 3D printing, and it is the direction the market will always keep pursuing. FDM technology seems to be the leading area where build volumes over 25 inches are becoming a household staple, and printing out car bumpers, pipes, boat hulls, and human-sized objects in one go is a readily available option. So now we will talk about really gigantic 3D printers with build volumes starting with 1 by 1 by 1 meters. The Modix Big Meter is an industrial self-assembly kit. With the minimum layer height of 40 microns and the impressive build volume of 1010 mm cube, it is capable of printing highly detailed parts of virtually any size. The Big Meter is equipped with a number of useful features, such as an automatic bed leveling system, a filament runout sensor, and a dual-zone silicone heater. The PEI print surface provides perfect layer adhesion and ensures hassle-free print removal. The list of compatible filaments includes PLA, ABS, composite materials such as carbon fiber, wood, copper, brass, PHA, PVA, HIPS, nylon, TPE and TPU, and PETG. The CreateBot F1000 is a large-format FDM 3D printer with a dual extrusion system providing multi-material and multicolor printing, and a build volume of a 1-meter cube. The machine can print with a variety of high-performance filaments for direct application, and is packed with all the features necessary for efficient 24/7 production of plastic parts with various materials on a large scale, namely a heated chamber, a filament drying room, an automatic bed leveling function, and an onboard camera. The intelligent power-off recovery and filament detection systems help to avoid the risk of printing failure. The device is compatible with a broad range of engineering-grade filaments, including ABS, PLA, carbon fiber, PETG, nylon, PC, flexible filaments, and others. The Delta Wasp 3MT Industrial 4.0 is an FDM professional 3D printer that can print with thermoplastics in both filament and pellet form. The minimum layer height is 100 microns for filament printing and 500 microns when working with pellets. The device features a fully enclosed print area of 1000 by 1000 by 1200 millimeters. Powered by an auto-feeding pellet tank and a pellet runout sensor for reliable, continuous printing, its extruders can process both technical and recycled materials. Wi-Fi connection for remote control via smartphone, tablet, or PC, and an integrated camera provide real-time monitoring. The Delta Wasp 3MT Industrial 4.0 is equipped with a print recovery function and a free Zeta system, which lets you start a print from a preset height. The Massivit 5000 is based on the unique gel dispensing printing technology that provides an incredibly fast printing speed of 300 millimeters per second. The printer uses the proprietary photopolymer acrylic gel as consumables, which ensures superb mechanical properties and fast curing time. The outstanding build volume of 1450 by 1110 by 1800 millimeters allows for the creation of extremely large models in one go. The Massivit 5000 features the dual material system and the mold mode designed for producing architectural elements, restorations, or street furniture with concrete or plaster casting. Resin 3D printers are widely used by businesses when accuracy, precision, and surface quality are at stake. Here, the trend also points towards larger build volumes and a more seamless transition from raw material to the final make on a scale as large as ever before. The recent introduction of 4K and 8K monochrome LED light sources increased the detail quality and curing speed of resin 3D printers. Likewise, the industry is switching from small desktop machines to larger format industrial devices without sacrificing print speed or resolution. Nexa 3D is the manufacturer of one of the world's fastest resin 3D printers, the NXE 400. The proprietary lubricant sublayer photo curing technology and the patented structured light matrix deliver quality printing at unprecedented speeds, making it full-fledged industrial equipment capable of large-scale production. With print speeds reaching 10 millimeters per minute and a build volume of 275 by 155 by 400 millimeters, the NXE 400 boasts a 4K resolution, ensuring high print accuracy and surface quality. Thus, the device is a perfect tool for a variety of tasks, from prototyping to serial production. SLS, or selective laser sintering, was an industrial-grade technology right from the start due to the fact of utilizing lasers for melting raw material powder. This type usually presupposes not quite large build volumes, but the precision and exceptional resolution along with layer-binding properties make SLS one of the most sought-after technologies when it comes to manufacturing high-quality and intricate parts, especially for functional use. When precision and high-impact materials come into play, SLS is an industry standard. If you want to learn more about this technology and the best SLS-based printer models, watch our video about selective laser sintering containing the overview of the best desktop and industrial SLS 3D printers. The Sinterit Niels 480 is an industrial SLS 3D printer which, according to the manufacturer, ensures the best return on investment on the modern SLS technology market. The device features a large build volume of 200 by 200 by 330 millimeters and industrial print speed which allows printing the full bed in less than 30 hours. The automated systems for continuous printing and powder dispensing stand for high usability and efficiency of the Niels 480. Sinterit offers a wide variety of proprietary materials, as well as optimized profiles for all of them. Still, the Niels 480 is an open system, and you are free to use third-party powders with your own profiles. The Farsoon 403P series is the flagship of Farsoon's plastic laser sintering printers. It comes in 3 different configurations, namely the HS403P, SS403P, and HT403P. The difference between them lying in the laser power, the scanning and print speed, and the maximum chamber temperature. The most powerful of the 3 is the HT403P. Its maximum internal temperature of 220 degrees Celsius allows for the use of FS6140GF and Ultrasynth PA6 high-temp powders. 403P series printers are able to print accurate, detailed models at high speed. The 8-zone heater and the intelligent thermal control system eliminate the risk of part deformation. The machines are a completely open system, which means that the user has free access to all operating parameters and is not limited to proprietary powders only. The 403P series also has two modifications that can be regarded as a separate lineup, which is called Flight. Flight, or fiber light technology, employs more powerful fiber lasers instead of carbon dioxide one used in the original 403P series. This allows for higher printing speed of up to 6 liters per hour, compared to 2.7 and 4 liters per hour with the usual 403P models. Due to the Flight technology, the models provide a more homogeneous energy distribution and better mechanical properties of the printed parts. The lineup includes Flight SS403P and Flight HT403P 3D printers, the latter featuring a higher maximum chamber temperature of 220 degrees Celsius, compared to 190 degrees Celsius in the Flight SS403P model. TPM 3D is a China-based company specializing in the production of SLS 3D printers and related consumables. The manufacturer's lineup includes several solutions that differ in build volume, number, and power of lasers, as well as smart features. The S600DL model represents a separate segment of TPM 3D's equipment. It is a powerful AM solution designed with two 140-watt carbon dioxide lasers, enabling an impressive scanning speed of 25,000 millimeters per second. The machine comes with a huge print chamber of 600 by 600 by 800 millimeters, and due to the open system inherent to all the company's devices, the S600DL can work with a remarkable selection of powders with different properties. When it comes to additive manufacturing in the industrial segment, one of the most prominent possibilities today is metal 3D printing, which is performed using SLM and DMLS technologies, as well as FDM and some others. We'll briefly cover the most common of them. Originally, FDM technology was focused on thermoplastics due to the low-temperature nature of processing such materials. However, there are several ways FDM can be effective in a metal printing industry. One way of introducing metals into FDM 3D printing is infusing conventional thermoplastic filaments with small metal particles. Although such materials may be compatible with consumer FDM printers, the resulting parts are basically plastic objects that resemble and simulate metal structures lacking the mechanical properties of all metal objects. So the solution is more decorative than practical. But some manufacturers took this principle to another level, introducing sintering into the process, which requires additional equipment. The sintering process removes the plastic binder from the printed part, fusing the layers closer together. However, this type of post-processing reduces the size and weight of the part. Fortunately, the software successfully deals with this problem. Besides, the final part can turn out to be porous, which becomes an issue in certain applications. Still, metal FDM 3D printers are widely used for various applications, as it's probably the least expensive method of utilizing metal materials in 3D printing. The Raise 3D Metal Fuse is a complete solution including the Forge 1 metal FDM printer, the D200E debinding machine, and the S200C vacuum sintering furnace. The system allows for efficient low to medium batch manufacturing of high-quality metal parts, comparable to full metal objects and mechanical properties. The Forge 1 printer is equipped with two extruders with the maximum hot end temperature of 300 degrees Celsius. The machine supports BASF UltraFuse 316L and UltraFuse 174pH filaments that consist of 80 to 90% stainless steel and 10 to 20% resin binder. As soon as the part is printed, the excessive binder is removed in the D200E catalytic debinding machine, and then the part is sintered in the S200C to obtain the required mechanical properties. The Mark Forged Metal X 3D printer employs FDM-based atomic diffusion additive manufacturing technology utilizing metal powder bound in a plastic filament. The latter is then removed in the Wash 1 debinder, and the metal powder is sintered in the Sinter 1 furnace. The resulting parts are solid metal, with the same strength and durability as metal parts that have been cast. The Metal X can 3D print with different metals, including stainless steel, tool steel, Inconel, and copper. With the resolution of 50 microns and a reasonable price, the Metal X is a powerful tool for industries relying on proprietary metal parts production on a limited budget. Selective laser melting and direct metal laser sintering are the two most common additive manufacturing processes that use metal powders. Less common technologies for 3D printing with metals include laser or high-power electron beam additive manufacturing, as well as binder jetting, where the process of 3D printing is implemented by applying and binding of the metal powder layer by layer. The differences between SLM and DMLS relate to the method of binding the particles together. With SLM, the metal powder is melted down by a laser beam, while in DMLS, the powder particles are heated with subsequent sintering while avoiding the solid to liquid transition. These technologies, as the majority of industry-focused tech, require elaborate post-processing and higher power consumption, not always available in a consumer-focused setting. SLM and DMLS printers work with a great variety of metals and metal alloys, including aluminum, stainless steel, titanium, cobalt chrome, and nickel chrome used largely by such industries as automotive, aerospace, medical, and dental. While 3D printing with precious metals such as gold, platinum, palladium, and silver is mostly used in jewelry. The Farsoon FS721M is an industrial metal 3D printer that offers a build volume of 720 by 420 by 420 millimeters, and dual or quad 500-watt laser system which allows fast printing of large-scale parts or batches of smaller-sized objects. Such features as continuous powder feeding, optimized gas flow, and integrated filter module are designed to achieve the uniformity of the part being printed, to ensure its decent mechanical properties and industrial-grade quality. The printer supports a wide range of both proprietary and third-party materials, with even more to come. The BLT S310 is aimed at SLM 3D printing in the fields of aerospace, automotive, healthcare, engineering, and electronics industries, as well as R&D purposes. The machine provides fast printing of high-quality metal parts. The intelligent powder-saving function allows increasing the cost-effectiveness of the printing process. Among the supported material types are titanium alloy, aluminum, high-temperature alloy, stainless steel, high-strength steel, tool steel, and copper alloy. The build volume of the printer is 250 by 250 by 400 millimeters. As you can see, there are a variety of solutions for industrial-grade 3D printing based on different technologies with their own benefits. For example, selective laser sintering is considered one of the most cost-effective 3D printing technologies, as it allows full loading of the build chamber to print a multitude of accurate and durable parts at a time, so it is widely used for small batch manufacturing. Metal 3D printing opens up new opportunities for many industries, as it allows creating functional complex parts which are difficult, if not impossible, to make with traditional methods of metal parts manufacturing. Quite a number of FDM printers, too, become significant players in an industrial setting, some of them being great tools not only for rapid prototyping but for the production of end-use parts as well. The choice of the equipment, as usual, depends on the requirements for the product created and your specific needs from the production. This is Top 3D Shop with the overview of the best industrial 3D printers. Subscribe to our channel, leave comments, and hit the like button if you've enjoyed the video. See you soon!